Welcome to Study Loop.
This is the answer to Chapter 24, problem number 67 from the Smith Organic Chemistry textbook. This problem asks us 5 questions about 2-acetylcyclopentanone. Okay, and so there are 2 indicated bonds, bonds A and B. And so for A, we're asked what starting materials are needed to form 2-acetylcyclopentanone by a Claisen reaction that forms bond A. And so basically we just need to think about cutting the molecule there and then doing a Claisen to reform it. So that would look like this. So there's our ester. And then we would have a ketone here. Okay. For part B, we're asked the same question, but about bond B instead. And so in order to form bond B by a Claisen, we would need these 2 starting materials. Okay. And so that's how we would form bond B by a Claisen. For part C, we're asked what product is formed when 2-acetylcyclopentanone is treated with sodium ethoxide followed by methyl iodide. So sodium ethoxide and then methyl iodide. So we will methylate, and we'll methylate at the more hindered alpha carbon. So there we go. There's our product for part C. I'm going to put D and E on their own page here. So for part D, we're asked to draw the Robinson annulation products formed by the reaction of 2-acetylcyclopentanone with methyl vinyl ketone. Okay, and so probably the easiest way to do this is going to be to redraw this. So there's our methyl vinyl ketone, and then we should redraw our starting molecule like this. So we'll put this ketone here and this ketone here. Okay, so now when we do this Robinson annulation, we get 2 possible products. And so they would be these. So that's one of our possible products. And the other product would look like this. That's not right. Let me draw that again. There we go. It's better. Okay. Oops, not okay. Ketone would be here in the second product. Okay, so there we go. There's the second product. So those are our 2 possible products for part D. And then for part E, we're asked to draw the enol tautomers. So it says draw the structure of the most stable enol tautomer or tautomers. And so there are actually going to be 2 of them. And so draw our starting material back out. So there are more than two tautomers that could form here, but the two stable ones, the two most stable ones, are going to be the ones that put the double bond in conjugation with the ketone. So we could tautomerize at this ketone. Tautomerize at this ketone, and so the double bond will be there in conjugation. Or if we tautomerize at the other ketone, double bond would be there in conjugation. And again, those are the most stable enol tautomers because they put that double bond in conjugation with the ketone. Okay, so there's D and E, A, B, and C. And that is the answer to chapter 24, problem number 67.